Okay. As a society, we have progressed immensely in the field of genetic engineering. Today, we create plants that contain genes for resistance, pests and herbicides, and we even create rabbits with bioluminescence from the addition of genes from jellyfish. We have come so far in the field of genetic engineering, so what exactly is the next frontier? So scientists have begun researching, or have been so far, the subfield of human genetic engineering, which comprises of somatic cell modification and germline cell modification. And however, the main area of focus is germline cell modification. Germline modification is known as, is basically the parent's egg or sperm is typically changed genetically, the goal of these changes being passed down to their children. Unfortunately, this potentially life-saving genetic engineering is still in the infancy and not yet being widely researched due to certain barriers. So currently, the United States the human genetic engineering is underneath the field of Federal Food, Drug, and Cosmetic Act and the Public Health Service Act. So that's what regulates everything, but however, there's been a ban on it, so no federal money goes towards this research. And me and Kyle's proposed policies, we should allocate more government funding towards human genetic engineering. And our first claim is that there are many genetic diseases that affect people which are debilitating, not only to the person themselves, but also to their family. Second, that genetic diseases are common and could be reversal with the help of germline modification. However, no steps have been taken due to insufficient research in human genetic engineering. And third, if we were to increase funding towards human genetic engineering research, we could progress towards reducing debilitating genetic disease in people. So for our first claim, the significance claim, to date there are 6,000 known single genes called monogenetic diseases that people can inherit. Every 1 in 10 Americans have some sort of genetic disease, and they can range from being harmless, such as having an extra finger, or having Tay-Sachs disease, which leads to the destruction of your own neurons in your brain. This is taken from discovery.com. And there are many aspects to consider when viewing a family that has members of genetic disorders. One aspect is finances. It's estimated to raise a quotable normal child for 18 years is $241,000. It's taken from CNN. And in contrast, caring for a child with mental retardation, which there's many genetic disorders causes such as Angelman syndrome and Fragile X syndrome, the estimated cost is $1 million. It was taken from cerebralpalsy.com. Another aspect in families that have members with genetic disorders is the emotional burden that comes from that. From the American Journal of Medical Genetics, the University of Manchester performed a qualitative study which explored the emotional effects that are common to many genetic conditions and the risks of genetic conditions. So 52 individuals that have genetic diseases were in the study, and they had many different interviews with these people. And the results provided that many common emotions when facing genetic disorders were depression, sadness, grief, uncertainty, anger, and guilt, especially anxiety and risks to your children. Concerning anxiety, a subject representative said it has a huge emotional impact because they know not only are they facing the parent's disability and problems, but they are facing it for themselves in the future. And the study also concluded that patients were very focused on the risk of passing their genetic disease to their children. One of the volunteers or the subject said, I mean, for me, the thing that differentiates this from any other kind of illness is an impact or potential impact on your children. That's what really hits you quite hard. It's a double whammy. It's bam, bam. And you can understand the feelings of, like, say you have a family member that has Huntington's disease, which is an extremely debilitating disease. You lose motor functions and cognitive functions. And when you have it, it's typically a 50% chance you're going to give it to your children, or you already have it. And the thing is, you don't know this typically because it comes on early age. Early age Huntington's disease is very rare. but you can be screened to have it, to know if you have it. So, and there's also examples of this, of research we've done, that there's infants born successfully with 3 different types of DNA, from 2 female, 1 male. So for our inherency claim, it said that genetic diseases are common and can be reversible with the help of germline modification. However, no steps have been taken due to insufficient funds. There is a ban from 1996 that says that there's currently no funding towards germline modification, and this is because it was called a 1996 Dickey-Wicker Amendment. It is legal to use federal funds to support research in which human embryos are created, destroyed, and discarded, or unknowingly be subjected to risk or injury or death greater than allowed for. So any funds that are going towards research in germline modifications are from private institutions and biotechnology labs that are well funded by themselves. So, but of course, funding would first go towards research in changing the germline of animals. These are small steps to be taken. As our understanding of how modifying the germline works, we could slowly take steps towards researching on human germline modification more than we already have. And for our third claim, the solvency claim, if we were to increase funding towards human genetic engineering, we could progress towards reducing debilitating genetic diseases. If further research was conducted, we can learn how to replace the genes that have genetic or residual debilitating consequences, such as Huntington's and Tay-Sachs and other PKU. So, and of course, research would be and should be focused on genetic diseases that are devastating, not mild to lesser consequences.